Hey everyone, today we're on Unit 4, Lesson 6, which is Properties of a Quadratic. So today we're going to start with just the basic quadratic equation. If we have an equation, f of x equals ax squared plus bx plus c, we know by now that when we graph this, we get a parabola. Okay, and when we go from highest power to lowest power, that's when the equation is in standard form. Your equation must be in standard form for you to be able to use any of the properties. Let's talk about what the two basic properties we're going to focus on today are. When we graph our parabola, hopefully you remember from your algebra class that we have this axis of symmetry running through it. So this line here, this kind of line we don't really see in the graph, is called an axis of symmetry. And to get that value, we use x equals negative b over 2a. And then our parabola always has what we call our vertex or our turning point. And that's going to be a point. That's going to be an ordered pair, x, y. The x value of that point is the axis of symmetry. And the y value of that point is what you get when you plug that x value into your function. Now, two last little things here. If a is a positive value, if our lead coefficient is positive, our parabola opens up, which makes our turning point or our vertex a minimum value. And if a is negative, or if your lead coefficient is negative, our turning point or vertex is a maximum value. Okay, so we're just going to use those concepts today, start out very, very basic, and then get into some more complicated word problems that we should be able to answer in this course. In the first example, we just want to find the vertex, the turning point of the given parabola, and then we're going to state, is it a maximum or a minimum value? So if I look at that function, f of x equals x squared minus 4x minus 5, remember, when we're looking to get the turning point, the vertex, we're going to use the x value of the vertex. So the axis of symmetry, negative b over 2 times a. So the x value of my vertex for this particular function is 2. And to get the y value of the turning point, I'm going to plug 2 into my function. And you could just use your calculator, plug that in. You should get negative 9. So the vertex, or my turning point, is the ordered pair 2, negative 9. And if we have to determine whether or not it's a maximum or a minimum, we look up front here. A is positive. It opens up. So this is going to be a minimum value. In example B, f of x equals negative 3x squared plus 6x plus 1. My x value for my axis of symmetry, negative b over 2 times a. Negative 6 over negative 6 is 1. Plug 1 in to get your y value of your vertex. And that answer should be 4. So the point 1, 4 is my vertex, my turning point on this parabola. And when I look up front here and I see that a value is negative, it means I have an upside down parabola. So that 0.14 is going to be the maximum value of the function. Now let's take a look at some different types of word problems, okay? So instead of just giving you and asking you, now we're going to have to kind of think a tiny bit. So we can use some of the properties of the quadratic to help us answer word problems when we need to find maximum or minimum values. For example, and this is a nice, easy example from like Algebra 2. The height of a ball thrown in the air is modeled by S of t equals negative 16t squared plus 200t. S is measured in feet, and t is in seconds. So before I even begin, let's kind of picture what's going on here. I know this graph is going to have a y-intercept of 0, 0. And if you plugged it in your calculator, you're going to get something like that. It's a negative 16t squared. Okay. Now, when we're dealing with t's and s's, our t is our x-axis, that's our time, and our s is our height of the ball. So I plug in t, I get s, which is height. And here's going to be my maximum value. So I need to use negative b over 2a to find when it reaches its maximum height. So t is going to equal negative b over 2 times a. And that is 6.25, and my time is in seconds. So at 6.25, that's the value I would plug in to get the maximum height. In the next part of the question, what is the maximum height? Now we're looking for the y value on the graph. And again, it's just as simple as the vertex plugging in. S of 6.25. Again, these numbers, I would just evaluate in my calculator. It's no big deal. And the maximum height for this graph is for this ball is 625 feet. Okay, so when is my x, or in this case, t, and what is my y value? Okay, that's very important. Now let's look at a problem that's going to kind of combine what we've been talking about for the last couple of days and what we've been talking about today. So we're going to have this situation and we're going to have to come up with our own function to use. A farmer has 200 yards of fence to enclose a rectangular field. What are the dimensions of the rectangle that enclose the most area? Important things in this problem: 200 yards of fence, dimensions of the rectangle, and the most area. So there's my fencing. Okay, there's my situation. I want to write a function for this rectangle, length times width. So remember the other day we talked about how, okay, so I'll make that x, I'll make that y. First thing I'm going to do, replace L and W with the pieces from the problem. Now when I look at this function, I have an x and a y. I have to get it to be all x's. So I go back into the words of my problem, specifically right here. 200 yards of fence means I'm going around that. This is my perimeter. I'm going to add up my sides. So my perimeter is going to equal 2x plus 2y, which is going to equal 2,000. Now at this point, I want to solve this equation, this secondary equation. Solve it for y, take that and substitute it in to my other equation. 2y is going to equal 2,000 minus 2x. Y is going to equal 1,000 minus x. Remember, we're going to take this guy here and replace it. I told you yesterday when we come up with these functions, we want to write them in standard form. The reason we want to write them in standard form is so we can apply our properties. So now if I want to find the dimensions, and remember, dimensions, length, and width. So I need to find the length. That's going to be the x value that's going to maximize the area. So I'm going to use the axis of symmetry, negative b over 2 times a. Negative 1,000 over negative 2 is 500. So when I use 500 yards, right, for my X, for my length, I'm going to have the maximum area. Now I have to find the corresponding Y value. So I'm going to go back over here to this guy. Y is going to equal 1,000 minus 500, and that's also 500 yards. It just so happens that a square is going to give you the maximum area, but a square is a rectangle, so it's okay. But you are going to have different types of situations, so don't always think that this is going to happen. The other thing I wanted to mention here is, what if I asked you for the maximum area? If I ask you for what is the maximum area, so be careful when you're reading the problem. You can use your area function, or you can just go back to your length times width. And whatever that value is, what is it going to be? 500, 500, I'm bad with my zeros. 250,000. And that's yards squared. Okay, so also notice my units. Now we're going to come to the doozy. This is going to be the problem that sort of puts everything together. A special window in the shape of a rectangle with semicircles at each end is to be constructed so that the outside dimensions are 100 feet in length. Find the dimensions of the rectangle that maximizes its area. I'm going to go in here and kind of look at some important pieces of information. Outside dimensions are 100, so that means my perimeter. Find the dimensions of the rectangle that maximize its area. So huge, most important, I have to come up with, now notice it doesn't say in the question, come up with a function. You have to know to come up with that function on your own. Now I'm going to go back to my picture for a second. That's going to be the length of my rectangle. And if we look at this shape here, this is actually a circle if we were to put them together. So my width, instead of using Y, I'm going to use 2R. My width is going to be 2R. So when I go back into my problem, my length is X and my Y is 2R. Now I have a little bit of an issue here. My issue is I have to find a way to rewrite this without the R. I have to find a way to relate the X and the R. And that relationship is going to come with my perimeter. The perimeter of this situation is going to be 2x plus, I've got this piece and this piece. So what's the perimeter of a circle? That's the circumference, 2 pi r. And that we were told that perimeter equals 100. And remember, we want to solve this for r, so we can substitute that in. 2 pi r equals 100 minus 2x. R is going to equal 100 minus 2x over 2 pi when we divide that through. If you simplify it in the beginning, it will make it a little bit easier to work with. So I'm going to take this r and now I'm going to pop it in. Oh, I think I made a tiny little mistake. That's okay. So I have 2x times that. So now I'm going to have area is going to equal 100x over pi minus 2x squared. No, take that back. I want to go in standard form right away. I'm so sorry, guys. So I have negative 2x squared over pi plus 100x over pi. That's much better. So now what we're going to do is, here's a little bit trickier. My area is negative 2 over pi x squared plus 100 over pi x. Okay, that's really a fraction out front. So this is your a and this is your b. So when I go to find out the x value that's going to maximize my area, negative b over 2 times a. And now notice, I have negative 100 over pi times negative 4 over pi. Your pi's are just going to cancel. And you really have 100 over 4, which is what? 25. I'm just going to give you a second there to check that out and look at that math that I just did. X equals 25 is going to be the length that maximizes the area. Now I need to find the width. Now think about it. Our width was what again? Our width is 2r. So I'm going to take the x value and I'm going to plug it in to my r equation. So a circle of radius r is going to maximize, but what we want to do is we want to find the actual width. And that width is going to be 50 over pi. Don't worry about what that value is. Don't worry that it's a messy number. Okay, pi is just 3.14, but you can leave it in your answer. So our width is going to be 50 over pi feet. And there you have it. Our answer is this guy over here. Those are the dimensions. If you were asked to find the area, I would have just taken the 25 and plugged it back into my area function. But again, whatever you find to be the easiest way for you to figure that stuff out would be good for you. And there you have it. It's a lot of math. It's not super easy. This is a challenging problem, and you may see something like this on your assignment. But I would not put this on a test because it's just way too long. And that's that. So go enjoy your day, everybody. Thank you. Bye.